But yeah, all of the things that we have covered in these 3 tutorials are usually the kind of things that Prof. Galbraith would put on his exams, but is a little bit trickier for students to understand. So it would benefit from more time being given to better understand them. So the first thing that I will cover today is a recap on the factorial. So last time we kind of saw the factorial at the end of class, but then the way that, the factorial is something that is slightly confusing. So it would benefit from being explained multiple times. So I'll just recap that the definition of n factorial means n times n minus 1 times n minus 2 times all the way until 1. Okay, so actually let me just get a better piece of chalk. Yeah, okay. So this factorial is just like when you write n factorial, it's basically an easier way to write n times n minus 1 times n minus 2 times all the way until 1. And you can imagine how if you have 1,000, you don't want to write 1,000 times 999 times 998 times dot 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 until 1. You can just write 1,000 exclamation mark. And then this basically is exactly what you want. And so last time what we covered is why the factorial is important, right? But this time I want to basically recap to you why the factorial is important, because this kind of thing is the kind of thing where like, the more you let it sit in your head, the more it begins to make sense. And so this is more of like a problem solving technique, because if I told you today, a factorial can be used to order n things, like you have 3 slots, you have 3 things you want to order them. I could tell you that you just take 3 factorial and you would be able to take that and you would be able to apply it, and that's okay. But if you understand better what does a factorial mean, then you'll be able to extend it beyond just this one specific situation and say like, okay, what if I have 3 slots and I have 2 identical things, but one that is different, right? So like, let's say if I have 3 slots and I have 2 blue balls and 1 black ball. So how do I order them? So that's why you need to care about what the factorial actually means. So I'll give you an example. Let's say in a bag, you have 3 things: a ball named A, a ball named B, and a ball named C. Okay? So in this set, there are 3 things. So what are all the ways that you can take out the balls out of the bag A, B, and C? A less abstract way is that you're trying to get Anne, Barbara, and Carmen to stand in a line. How many different ways can you get them to stand in a line, where obviously Anne is different from Barbara and Barbara is different from Carmen, right? So the reason why you get 3 factorial is 3 times 2 times 1, right? So what you have is, at first, for the first option, you can have 3 people, because you can either have Anne here, or Barbara here, or Carmen here. Okay, so you have 3 people, A, B, C. Then for the second slot, if you have Anne here, since you already have Anne here, you can't have Anne and Anne again, because there's only one Anne. So Anne can't like clone herself and suddenly you have like more than 3 people. You only have 3 people, right? So if you have Anne here and Anne is given as the first person, then you only have 2 options left here: Barbara or Carmen. For Barbara, if you have Barbara given as the first choice, then you either have Anne or Carmen. If you have Carmen here given, then for the second option, you only have Anne or Barbara. Does that make sense so far? So then here's the situation where for the second person, the first person, you had 3 choices. For each of the 3 choices, for the second person, you have 2 choices. 1, 2, 1, 2, 1, 2. And then given that you have Carmen and Anne here, what's the last person that has to be? It has to be Barbara. Given that you have Carmen and Barbara here, what's the last person? It has to be Anne. Given that you have B, A, then this has to be C. B, C, this has to be A. A, B, this has to be C. A, C, this has to be B. So I'll just fill this in. And this is all the ways that you can order them. But if you just remove these confounding factors, right? It's basically saying that for the first person, I can choose between 3 people. And once I choose the first person between 3 people, I can choose between 2 people for each of these branches. So if Anne is here, then I have 2 options for the second person. If Barbara is here, I have 2 options for the second person. If Carmen is here, I have 2 options for the second person. And then the last person, I have no choice. So Anne, I have 2 options for the second person. So I have Anne, and then it splits into 2. So 1, 2, 3, 4, 5, 6, which happens to be 3 times 2 times 1. So at the first point, I have 3 options. The second point, I split into 2 options. So for each of these 3 options, I have an additional 2 options. And then for the last point, for each of these 6 options, I only have 1 option left. So it has to, then you have the total number of orderings you get is equal to 3 times 2 times 1, which is 3 factorial, which is equal to 6. So this is what a factorial means. Do y'all have any questions so far? All right. If not, then we can see that, yes, this is the number of ways that we can order A, B, and C. Or we can put Anne, Barbara, and Carmen in a line. So I can put Anne first, Barbara, Carmen, Anne, Carmen, Barbara, Barbara, Carmen, Anne, Barbara, Anne, Carmen, Carmen, Barbara, Anne, and Carmen, Anne, Barbara. Of course, when you only have 3 people, you can write down every single option, right? But then if you follow what I say, and I tell you that 3 factorial is the number of ways you can order them, then what if you're trying to order 6 people in a line? You would have 6 times 5 times 4 times 3 times 2 times 1. So this would be 6 times 4 times 5 times 6, which would be 24 times 5 times 6, which would be, basically you can see how very quickly you don't really want to write down every single possible way that this can happen. You don't want to write down like A, B, C, D, E, F, and then A, C, D, B, E, F, and then like you're going to be writing forever. And so that's why knowing that it's 6 factorial is important. So this is factorial. So I'm just going to write the top factorial. And so number of ways to order n objects. So that's what factorial means. And so now we'll be moving on to what's a permutation. So I'll erase this if all okay. All right. So the next thing we'll be covering is something called permutation. Permutation kind of is something like the factorial, but imagine you only have 3 slots, but you have 5 people. And you care about which order that they come in. So let's say you have a race and you only care about the top 3 people. So how many ways are there to get a top 3 people from 5 people? Does that make sense? So like, let's say there's person 1, person 2, person 3, person 4, person 5. From person 1 to 5, you have to choose 3 people to be in the top 3. Not only that, but if person 1 comes first and person 2 comes second and person 3 comes third, that's a different ordering than if person 3 comes first, person 2 comes second, and person 1 comes third. These 2 are different, like inherently different orderings, because you don't say like, oh, the first 3 places in a race are all equal. It doesn't work like that, right? So here is where the ordering will matter. But of course, not everyone can be in the top 3. Because let's say, right now I'm only giving 5, right? But let's say there's like 100,000 people in the race, and you only care about the top 3. how many ways are there to get a unique ordering of top 3? This is what permutation deals with. So if let's say there's 100,000 people, it would literally be 100,000 P3, which is how many ways can you choose 3 from 100,000 where the order matters, which is basically where 1, 2, 3 and 3, 2, 1 are different. Does that make sense? All right. So this first number is we call n. Second number is k. So how many ways can we, how many ways are there? So npk, how many ways are there to choose k from n, where the order matters? And this npk, I'll actually make some space for it so I can write it super big. npk equals to n factorial divided by n minus k factorial. So this is the formula. And I can also justify you why this formula is like this using the exact same reasoning why a factorial is a way to order things, right? So if you remember just now, if we have a set A, B, C, we have this set. We're trying to order them A, B, we're trying to put them in order. And Barbara and Carmen, right? So over here, for the first one, we have 3 choices, so it's 3. For the second one, we have 2 choices left, so it's times 2. For the last one, we only have 1 choice, so it's times 1. And this is how we got the factorial formula, right? But then let's say, now that our S, well, I won't use S. Now that our, okay, I'll say S prime. Our new set of objects is Anne, Barbara, Carmen, David. Or A, B, C, D, whichever, if it helps you to think of people standing in a line, then that's great. Roll with that, right? But still, there are only 3 choices. 1, 2, 3. So for the first person, how many different people can be in the first place? So it's 4, right? So it's either Anne, Barbara, Carmen, or David. So we have 4. Second person, how many people can be in the second place? Well, once we take up the first person, it's already fixed. Then we have 3 left. Last person, we only have 2 left. So this equals to 4 times 3 times 2. But if you notice, 4 times 3 times 2 is just equal to n, where over here n equals to 4, and then k equals to 3. So it's 4 exclamation mark times 4 minus 3 exclamation mark. Does that make sense? So over here, this is what's important, is that 4 times 3 times 2. Let's say you have more objects in this set. You can even make this E. And then this will change because, okay, for the first person, how many options do you have for the first choice? 1, 2, 3, 4, 5. Any of these can be in the first slot, so 5. Then once you put one of them in the first slot, how many of them can be in the second slot? 4. Then 3, right? So then how many total ways are there is 5 times 4 times 3. This 5 times 4 times 3 is equivalent to 5 exclamation mark divided by 2 exclamation mark. You just cut them off at the 2 times 1 part. You just erase this by dividing by 2 exclamation mark, like by 2 factorial. Does that make sense? Yeah, so That's what the idea of a factorial comes from. So this can extend to any number of items. This can have any number of spaces. Sorry, that's where a permutation comes from. So this is, yeah, so basically this is what a permutation means. I'll write it at the top. If y'all have any questions, please feel free to unmute at any time. Because like combinatorics can be tricky to understand. And the best way you understand is by like playing with the ideas in your head. And then if something seems weird, you ask questions and then you'll get a better understanding of what it means. So let's say permutation is NP K. P stands for permutation. So that's how you remember it. NPK, which equals to n factorial divided by n minus k factorial, which is the number of ways to choose k items from a set of n items where order matters. The most important part is that this line that says that order matters. Why? Because the next thing I'm going to introduce is something called combinations. And combinations is basically a unique version of permutations where order does not matter. But first, like, if y'all have any questions about this? All right. If not, I guess I will erase all of this. Next thing we'll move on to is something called, let me see if this is visible, right? Okay. Combination. So how we define combinations is the number of ways to choose k items from a set of n items where the order does not matter. The most important part is that the order does not matter. So let's say if you're trying to pick, like imagine you have like 10 friends and you want to choose who to go on a vacation with you. You only have 5 slots. Well, it doesn't matter if friend 1 is in the first place and friend 2 is in the second place and friend 3 is in the third place, because all of them are going to end up going on the vacation with you, right? So in this case, it's like, or let's say you're having a lottery, and for this lottery, you have a situation where everyone who like you have, like, let's say you have 1,000 people enter a lottery, and you'll have 3 winners. All of them will win the exact same prize. So it doesn't matter. So let's say you put all of these 1,000 names into a hat. So all of these 1,000 names go into a hat. And then from this hat with all these names, you pick out people one at a time. Okay, first person who won, Anne. Second person who won is Barbara. Third person who won is Carmen. But all 3 of them are winning the exact same prize. So Anne being picked first, Barbara being picked second, and Carmen being picked third is the exact same thing as Cameron being picked first, Barbara being picked second, and Anne being picked third. Because it doesn't matter which order in which your names get picked out of a hat, you're still going to win this exact same grand prize, let's say a cruise trip or whatever. So this is essentially what combinations mean. When all of them are going to get the same thing. Yes, what's written on? Number of ways to choose k items from a set of n items where, this is really bad handwriting, I'm sorry. where order matters. Is that okay?
I think it really depends on the product. So, and what part of the product also, like for example.
All right, awesome. So yeah, then so combinations is number of ways to choose k items from a set of n items where order does not matter. N can be picked first, Barbara picked second, and Carmen picked third. Carmen can be picked first, Barbara can be picked second, and Anne can be picked third, but they all win the same grand prize. So it doesn't matter. And we're trying to, like, if we just use permutations, you'll be double counting a lot of situations, right? Let's say from these 1,000 people, I'm picking 3. If I use NPK, I'm double counting so many situations because let's say A, B, C will be counted, but B, A, C will also be counted. What else will be counted? C, A, B will also be counted. So every single way that you can order these 3 items will be counted extra. How do we get rid of all of these extra counts? Well, that's where we go back to the idea of a factorial, right? So the factorial is the number of ways to order n objects. For each of the choices of A, B, C, they're counted extra by 3 factorial times because there are 3 factorial ways to order this, as we have covered before. Remember from before? It's A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A. Each set of three items from this set of 1,000 is counted extra 6 times. So what's the number of ways to count where order does not matter? So then this gives us the natural idea that n choose k, which is basically number of ways to choose where order does not matter, equals to the number of ways to choose where order matters, n permute k, divide by the number of ways to order this k. Does that make sense? Because for each set of 3 from this 1,000, you're counting it an extra 6 times. Because each set of 3 can have 3 factorial extra orderings. So if I take all of them and I divide 3 factorial for every single one of them, then what I get back is a situation where A, B, C will only be in there once. So there's no ordering, it's just a set A, B, C. Doesn't matter which is first, second, or third. As long as all 3 are chosen, it's a unique thing. And ABC equals to CBA. These aren't seen as 2 different situations. Does that make sense? So just as a recap, combinations are the situations where order does not matter. How do you get the number of ways to count to choose k items from n items where order does not matter? What you do is you take the number of ways to choose k items from a set of n items where order matters, and you divide by all the ways that these k items can be ordered. So that ABC is ACB, BAC, BCA, CAB, CBA. There's 3 factorial ways to order the set of A, B, C. So since A, B, C is counted 6 times instead of 1 time like we want to, we just divide everything by 6, right? So we just, in this situation, we just divide. Let me just clear some space. Sorry. Bye-bye magic hat. In this situation, we would just, so n was 1,000 as we discussed. Choose 3 people where order does not matter, equals to, if you choose 1,000, the number of ways to choose 3 people from 1,000 people where order matters divided by the number of ways it's counted extra. So how many ways is it counted extra? It's 3 exclamation marks. So 3 exclamation mark.
Right.
But this, according to the formula, equals to 1,000 exclamation mark divided by 1,000 minus 3 exclamation mark, 3 exclamation mark. So this gives us the formula for combinations. Because here 1,000 is n, 3 is k, and here 3 is k, 1,000 is n. So we have the formula for n choose k. From a set of n items, you choose k items, where order does not matter, is the number of ways that you can choose k items from n items where order matters. Divide by all the ways that you can order them, which equals to n factorial divided by n minus k factorial, k factorial. Does that make sense? And if you all have any questions, you can pause now and you can cover them. Because this is basically all of like the combinatorics that we're probably going to cover, and all the combinatorics that I think Galbraith covers. Because like there are other ways that you can go deeper into combinatorics where like, okay, what if you have, 2 that are the same and 1 is different? Or like, what if you're trying to order them in a circle or whatever? That's like, there's additional stuff. But the most important thing is that you understand factorial, permutation, and combination. Where do these formulas come from and what do they actually mean? And then when you look at a question, you can be like, okay, I know how to do this because all I need to do is see like, there's 1 slot, right? So how many people can fit in that slot? There's a 2nd slot. How many people can fit in that slot? Does that make sense? I will take a small water break. If any of y'all have any questions, you can ask in the chat, or you can unmute and just ask.
No worries, it happens. It happens. All right, have a good day. Bye-bye.
Okay, I have a question from someone. The recordings will be posted on YouTube. The Econ Student Association has a YouTube page where they've also posted past recordings. And the past recordings are still useful because I didn't really cover a lot about statistics like covariance, mean, and variance, and all of that kind of stuff. Because I feel like, most people usually start with probability and then they start moving into that wonky stuff. So if you need help with that kind of stuff, you can also go to the past recordings from last year. And also 2 tutorials. Yes, there will be a recording for the 2nd tutorial, but for the 1st tutorial, I'm so sorry, I forgot to record it. Anything else? Could we continue this example with numbers and plug it in? So the 1,000 choose 3. Yeah, sure, we can continue it with numbers. But you would see that I will use 4 choose 3. Okay, because 1,000 factorial is just a gross number. Yeah. Actually, no, wait. This is fine. This will teach you a useful property anyways. Oh, I shouldn't have erased that. Never mind. Okay. So 1,000 factorial equals to 1,999,998,997 ... until 1. You multiply all of them, okay? And then you divide by 1,000 minus 3 is 997, if I'm not wrong. 996 ... until 1. And then multiplied by 3 times 2 times 1. Okay, this is just basically expanding this. But then if you see 1000 times 9999 times 998, sorry. 1000 times 999 times 998 times 997. From here onwards, times 997 crosses, from 900 times 996 crosses, all the way until everything beyond here just cancels out each other. Does that make sense? Because you can also rewrite 1000. I'll write this on the side so I don't confuse you. You can also rewrite 1000 factorial to equal to 1000 times 999 times 998 times 997 factorial. And then in that situation, 997 factorial will cancel out with the 997 factorial over here. And so what you have left is 1000 times 999 times 998 divided by 3 times 2 times 1. So I'll just take the easy ones away. So 1000 divided by 2 is 500. 999 divided by 3 is 333. And then we have 998. 998. Okay. So this is the number of ways to choose 3 items from 1000. To choose 3 items from 1000 items such that the order does not matter. It's this many ways. Unfortunately, I probably can't bring you past here because you have a calculator, so that would be easier for you. I'll send you the name of the YouTube channel later after this recording. But does this make sense? So basically, you can split this 1000 factorial into 1000 times 999 times 998 times 997 factorial, which is this term. So then you cancel out this with this, and then you have this 3 left. 1000, 999, 998 times divided by 3 times 2 times 1. Okay, perfect. I'm glad that makes sense. So now I'll clear some space so I can write the definition of combinations at the top, okay? So let's say combination is N choose K. And as the formula, I'll erase all of this. Actually, I wrote that a little bit too high. Combination equals to N choose K, which equals to N factorial divided by N minus K factorial, which is the number of ways to choose K items from a set of N items where order does not matter. The only difference between permutation and combination is over here, order does not matter. And that's why you divide by the number of ways you can order the K items. Okay? And if you have any other questions, feel free to stop me. But now we're just going to go into some exercises, so you can see how it's actually used. I think do you all want me to do a recap on some conditional probability? Okay, I'll save this for the end. So okay, repeat the definition of combination. Okay, so combination is N choose K, which is the number of ways to choose k items from a set of n items where order does not matter. So let's say I have 10 friends. I want 3 of them to go on a retreat with me. If I choose 3 of them, it doesn't matter if I choose my best friend first, my second best friend second, and my third best friend third, because they're all going to go on a retreat with me, right? But how many ways can I choose these people? How many different people can go on a retreat with me? That's 10, choose 3. Does that make sense? Okay, awesome. So I'll just skip straight to question 10b. Okay. So question 10b, I won't cover question 10a because it's conditional probability. If we have time at the end, I'll loop back to it because it is a tough conditional probability one. So question 10b says that a government agency monitoring safety is comparing results from 2 major manufacturers of Ferris wheels, Consolidated Rides, CR, and Blue Sky Amusements, BSA. It compares accident rates from 6 CR rides and 8 BSA rides. If the 2 manufacturers in fact produce equally safe products so that any differences are purely the result of random chance, what is the probability that the top 3 highest accident rate rides are all from BSA? So over here, a really important thing is that if you want to use combinatorics, at least in the way that I have shown you, you must say that the 2 manufacturers in fact produce equally safe products. Because as I told you that, because if you just take the number of ways to order things and you divide by the total number of ways, basically the solution would be you take the number of ways that the top 3 that are from BSA, divide by the number of ways to choose the top 3, right? But that wouldn't be valid if BSA is indeed less safe than CR. Because if the Blue Sky Amusement Ferris wheels are indeed less safe than CR, if we just take that number of ways top 3 are BSA divided by total number of ways to choose top 3. If we just say that this equals to the probability that the top 3 are from BSA, that means that we're implicitly saying that there's an equal chance that all the top 3 are from BSA, that they are from anywhere else. Because if you're imagining the 1, 2, 3, right? If we say that here is a BSA person, here is a BSA person, here is a BSA person, we must have an equal probability that it could be you cannot say that BSA is less safe than CR because that changes the probabilities. Now it's not just the number of ways that the top 3 are BSA divided by the total number of ways to choose the top 3. Now there's some probability that BSA is in the top 3 that is different. Does that make sense? It's like a confounding factor. I feel like that wasn't explained really well, but if you have any questions about that, you can stop me, or any clarifying questions about that. Okay, so just really importantly is that in the question, he says that they actually have equally safe products. So then the probability top 3 from BSA equals to the number of ways the top 3 are from BSA divided by the total number of ways to choose the top 3. So everything is just up to random chance, okay? We just randomly pick out of the hat the top 3. If we couldn't randomly pick out of the hat the top 3, then we can't use combinatorics because that's basically what it is, randomly picking them out of a hat. What's the chance that like when I randomly pick 3 things out of a hat that the top that it's that you would have that they're BSA. So what are the number of ways that the top 3 are from BSA? This comes to the question of how many are in BSA in the first place. There's 8, right? So then we have 8, choose 3. And then what's the total number of ways that we can choose the top 3? There are 14 total rights because 8 plus 6 equals to 14. So there are 14 total rights from both CR and BSA. So it'll be 14, choose 3. If we go back to the same kind of reasoning that we used before, you have 3 slots for your top 3. This is number 1, this is number 2, this is number 3. If we're trying to find the number of ways that the top 3 are from BSA, so how many can be in the first one? There are 8 BSA rights, so 8. Once we pick a right over here, then we only have 7 left here. 7, 6. So 8 times 7 times. So over here we have 8 times 7 times 6. But not only that, but we want to remove the difference between right 1, right 2, right 3, right 3, right 2, right 1, and so on, because you just want that the top 3 are in BSA. You don't care that the top 3 are this, the one of them is this specific one, the second one is this specific one, the third one is this specific one, right? So then you have 8 times 7 times 6 divided by the number of ways to order them, 3 exclamation mark. Does that make sense? So that's the number of ways that the top 3 are from BSA. What's the number of ways to choose the top 3 in general? So again, we draw the 1, 2, 3. What's the number of ways to take the combination of 3 objects from 14 objects? Same thing, 14 times 13 times 12 divided by the number of ways that you can order this. Does that make sense? So over here, we get exactly this, right? So this equals to 8 times 7 times 6 divided by 3 exclamation mark, 3 factorial, divided by 14 times 13 times 12 divided by 3 factorial. So if I write this all out, it'll be 8, 7, 6 divided by 3 factorial divided by 14, 13, 12 divided by 3 factorial. This equals to 8, 7, 6 divided by 14, 13, 12. And then 7, 14 is half, 6, 12 is half. So 7 divided by 14 is half. So this will be 1 over 2. This will be 1 over 2. So it's 8 over 13 times 2 times 2, which equals to 26, 52, 52. 8 divided by 52. Is that it? Yeah, it is. Is that okay? All right. So yeah, if you have any questions about this, it's crucial that you ask it now. Because if you just let the doubts linger in your head, things will just get kind of more confusing, because you're just after you move into the cloud of confusion, it's very hard to unconfuse yourself. So I'd be happy to clarify about any single part of this. And if you have a question, it's probably that your other friends also have the same question. So it's useful for you to unmute and ask so that your other friends can learn as well. Is that okay? the BSA part. Okay, so the BSA part, I'll just erase this probability thing first, okay? How about now? We just try to focus on, yeah, let's just erase all the computation, okay? Now we just want to focus on what are the number of ways that the top three are from BSA. We only care about this thing right now. So what is the number of ways that the top three are from BSA? So 1, 2, 3. These are your top three. We want to know what's the likelihood. Okay, let's say in BSA, since there's 8 rides, we have BSA 1, BSA 2, BSA 3, all the way until BSA 8. This is a set of all rides from BSA. Okay? Now, we want to find the number of ways that the top three are all in BSA. That's equivalent to saying, what's the number of ways you can order these 8 items in the top three? Because we know necessarily that you want the top three to all be from BSA, right? So you can have B8, B7, B6, or you can have B1, B2, B3. All you know is that you want these top three to all have the subscript, to all have the letter B in it. So what's the number of ways that you can get the top three to all have the letter B in it? If you take 8 times 7 times 6, as we mentioned before, this is a good first step. But the problem with 8 times 7 times 6 is that what it's counting, it's counting things multiple times. Right? Let me just write 8 times 7 times 6 here. 8 times 7 times 6. It's counting things multiple times. So B1, B2, B3 is being counted. But what else is being counted is B2, B1, B3. What else is also being counted is B3, B1, B2. And as we remember before, if I could write all of the ways that it's being counted extra out, but as we remember before, it's 3 factorial. Does that make sense? So all of these are the number of ways, and there are 3 more, because 3 factorial is 6. There are 3 more ways that it's being counted extra. But then how do we deal with that? So these are the number of ways you can choose 3 items from a set of 8 items where the order matters. And then you divide it by the number of ways you can order it, 3 factorial. Right? So once you divide it by the number of ways you can order it, which is 3 factorial, because I could write down B1, B3, B2 in the middle, B2, B3, B1 in the middle, B3, B2, B1 in the middle. So there'll be 6 total, right? There are 6 ways to order every set of 3 that I pick here. Let's say I pick B2, B4, B6. This is a possible selection of top 3. But then if I just count 8 times 7 times 6, then I'm counting extra 6 times. So I need to divide by the 6 for all of the ways that you can order this 3. And so that's how you get the number of ways that the top 3 are in BSA. It's just you take the number of ways to get 3 from 8 where the order matters, and you divide by the number of ways that you can order it. And this equals to 8 times 7, which equals to 56. Does that make sense? Yeah. So the most important part is that you get this part. Because if you get this part, then this second part just follows, right? What's the total number of ways to choose the top 3? So over here, we have a set of 14 rides. Not only have B1 to B8, But you also have C1, C2, all the way until C6, because there are 6 CR rights, right? So we're just trying to find a number of ways that you can order the top 3. You can like a number of combinations of the top 3 that you can get. Sorry, not the number of ways you can order the top 3. The number of combinations of the top 3 that you can get. So with the same principle that we used before, how many rights can be the number 1 right? 14 rights. How many rights can be the number 2 right? After you already have a right in the number 1 right, you can't count it again because a right can't be both rank 1 and rank 2. So you have 13 left. Once you have your rank 1 and rank 2, then you have only 12 left for your rank 3. But then this, as we have mentioned before, is double counting so many things, right? It's not even double counting, it's counting it an extra 6 times. So we need to divide all of this by 3 factorial to account for the number of ways that this is being counted extra. So I'll give you an example of the number of ways that it is being counted extra, just so like you're sure that you understand. So let's say the first one is C1. The second one is C2. The third one, this third one, is B1. This is one combination of the top 3 possible rights. But then if you just take 14 times 13 times 12, it's also counting in the number of ways that you can get 3 items from a set of 14. Get these 3 items from a set, the large set of 14. It's counting this, but it's also counting C2, C1, B1. It's also counting C1, B1, C2. It's also counting C2, B1, C1. It's also counting B1, C2, C1, B1, C1, C2. It's counting it extra this many times. And as we've mentioned before, since there are 3 items here, and this is an ordering of 3 items, we go back to the definition. This is the factorial, the number of ways to order n objects. Here, n is 3, right? So what's the extra number of ways it's counted? It's n factorial. So you have 1, 2, 3, which would be 3 factorial, which equals to 3 times 2, which equals to 6. If you look at this, it logically makes sense because if you count 1, 2, 3, 4, 5, 6, it matches with how many extra ways you can count the same set of 3 items. So when you take the total number of ways to choose 3 items from 14 items where order matters, and you divide by the order over here, so that you get rid of all these extras, then you would get the total number of ways to choose the top 3 from a set of 14 rights. Is that okay? So over here with some computation, we know that 14 times 13 times 12 divided by 3 times 2. 3 times 2 is 6, so 12 divided by 6 is 2. So it's 14 times 13 times 2, which equals to 364. So if we go back here, the probability that the top 3 are from BSA is the number of ways that the top 3 are from BSA divided by the total number of ways to choose the top 3. Because very, very importantly, we said that all of this is up to random chance. So as we have discussed before, the number of ways that the top 3 are from BSA equals to 8 times 7 times 6 divided by 3 exclamation mark. Well, 3 factorial. Over here, the total number of ways to choose the top 3 equals to 14 times 13 times 12. 12 divided by 3 factorial. And so if we solve this, this equals to, yeah, 56 over 364 as in the notes. And yeah, I mean, I think you could simplify this further, but it's not really the important point. The important point is that you get how to get a number of ways to get the top 3 that are in BSA, get how to get a number of ways to choose the top 3 in total. And then everything else just kind of follows. And the more that you do these kind of practice questions, the more that you'll get used to this kind of thinking. I just realized we're a little over time, so I guess we'll stop here for today. But if y'all have any questions, I'd be happy to take them for. Let me stop the recording.